Hold off speaking. Pat, you are live.
Welcome, diveLIVE family, to yet another dive here at Casuarina Point in Grand Cayman. Today I am diving on the left-hand side of the reef here at Casuarina Point, and I'm currently at 8.6 meters, so I am about 30 feet down. Now today we have Riyadh on camera, the stupendous South African. On the surface we have the always beautiful Lauren as your marine biologist up on top, and I am Pat, and I will be your underwater marine biologist today. Now we have found a giant anemone down here, so while we're going to have a look at this, why don't you say hello to everyone, Lauren?
Hi everyone, welcome to yet another exciting live dive. So Pat, tell us what you have for us right now. I believe the anemone has something very exciting inside.
Yes, so there is a giant anemone here, and I believe there is a crustacean of some sort.
It is a crab, a little crab hiding out there. So I'm not sure what species of crab this is because I can't get a close look, but it's very, very, very small, and you can see it's white and black little pincers there. It looks like it's got algae on top of it as well. It's obviously hiding out in the anemone.
Yeah, so this is what we call a symbiotic relationship. And what symbiosis is a interaction between two animals. Now, depending on how this interaction goes, is how it is classified. So this one right here, it's hard to say exactly. Well, we know the crab is benefiting here in this situation because it can obviously tolerate the anemone stings and is using the tentacles for protection. Now, in return, I'm sure the crab would defend this anemone as well with its claws. So they're both kind of protecting each other. And so because they both benefit from this interaction, it is called mutualism. When if this crab was damaging the anemone in some way, but still benefiting, so one benefiting while the other one is harming it, that is called parrotfish, which is where the word parasite comes from.
Yes, and I can confirm it is the banded clinging crab. So I'm not an expert on crabs, but that's what the species is, and it really is just hiding out there. And as Pat mentioned, the anemones can have stinging cells, so normally for crustaceans, which include both crabs and shrimps, they have to slowly almost immunize themselves against the sting and build up the tolerance before they can actually just settle on an anemone like this.
Yeah, so it's a hard road to get there, a hard and painful road. But it is worth it in the end because they don't get eaten.
That is true. And Pat, you'll be happy with this. We do have a request from Yvonne asking to see the grey angelfish again.
Oh, grey angelfish. So we did have one of these the other day, but that was the first time we've ever seen one live. So I will be on the lookout for another one.
Yeah, it would be great to see a grey angelfish again because we do normally just see the French angelfish.
Alright, well, let's follow this channel out a little bit deeper. And while we're on the way, I will be checking all of these cracks and all of the little caves for a spiny lobster or two.
Ooh.
And then we will be following this channel out to the sand where I'm really hoping we can see a stingray, but also this left side has been very turtly lately, so I would also love to show you all a turtle, in particular a green turtle, because we haven't had a green turtle live yet, but I did see one out on this left-hand side the other day, so they are around.
And I would be incredibly jealous if you did see a green turtle. Happy but jealous. So what is the water temperature today? Some people have been asking about the weather. So on the surface, it is absolutely glorious. The sun is shining and all is back to normal. What's it like underwater, Pat?
Yes, well, we are pretty shallow at the moment. So I am getting that sun rays down. But as for the temperature, it tends to stay pretty constant down here. So at the moment, it is 27 degrees Celsius, which is about 81, 82 degrees Fahrenheit.
So Pat, Big Texa was just asking, as the feed was cutting out when we were having a look at that anemone, how is the crab benefiting from this relationship? If you could just go over that again.
The crab benefits because the stinging, sorry, I'm not trying to say this. So the anemone has these tentacles that have nematosis or stinging cells on them. So when something that isn't used to these cells comes past, they will get stung. So if the crab is hiding in amongst the tentacles, then it is immune to the sting, then anything that comes and tries to eat the crab is going to hit the tentacles first and get a nasty sting. So that's how they protect the crab.
Yeah, so it is a symbiotic relationship. So Pat is diving just to the left side of Casuarina Point today, which is in Grand Cayman, and we're just outside Don Foster's, our favourite spot. And I have to say, Pat, it looks beautiful down there. It's kind of unexplored territory.
Yeah, the lighting at the moment is great. So all of the really vibrant hues of the reef are really coming out. It's looking fabulous.
So please do remember just to send in your questions or even your requests, which we will do our best. If you are on Twitter, make sure you use that hashtag diveLIVE, and we will also catch your questions on YouTube and Facebook. So please do send them in, and we will do our best to answer them for you.
So this side of the reef is quite different to the right hand side that we usually dive. It is quite a lot more complex in its structure or its topography, and so this really gives opportunities for the real cryptic species to hide out, such as a moray eel or a spiny lobster or even the elusive octopus. Wouldn't it be great if an octopus came out to play today?
It would be amazing. And CJ is actually requesting a nudibranch. So Rianne, keep those eagle eyes peeled for a nudibranch for us.
Yes, Rianne has been the only one able to spot nudibranch so far here in Grand Cayman. They are very small and very hard to find. We've got a spot-fin butterfly cruising past right now, and it is very unusual to see one of these fish without its mate. So usually butterfly fish will hang out in pairs, and these mating pairs kind of mate with each other for life, but this one today is flying solo.
Child of the Universe is requesting a mantis shrimp, so that would be great to get one in honor of Simone.
Yeah, she loves her mantis shrimp, and she would be very jealous if we found one. They are more nocturnal mantis shrimp. They are known to come out at night more than the daytime, but when we head out to the sand, we will have a look anyway, because you never know what we're going to see out there.
Yes, you are all requesting the tricky ones to find, but we will do our best. So Pat, going back to that crab and the anemone, Big Texa, I maybe asked the question a little bit wrong, was asking if it is a beneficial relationship. Does the crab help out the anemone in any way? So what are the two benefits on either side?
So for the crab, the anemone is protecting it because the anemone can sting other things, and by hanging around the anemone, this is going to help the crab. Now, crabs are feisty little animals, so if anything comes and tries to eat the anemone, the crab is going to take this as a personal attack on it because it's essentially attacking its home. So they have these little claws, these little nippers that they will use to defend their territory and tell anything to go away, which is stopping the anemone from also being harmed. So they're kind of helping each other out.
So while we're just looking for our next critter, Proud Cat Mama is asking, why are coral reefs important to the ecosystem? So on you go, Pat.
Well, there is a large number of reasons why coral reefs are important. As I was saying just before, these reefs are extremely complex in their topography. So they create quite a bit of structure that serves a few purposes. Firstly, it can act as a home for many species of all types of marine organisms: crustaceans, fish, mollusks, anemones, cnidarians, corals. So firstly, it acts as a home. Now they can also protect these animals from attacks and also aid them in predation. They also harvest a whole heap of nutrients from the sunlight because corals do have symbiotic algae living within them. Oh no way, it's a grey angelfish.
Oh my goodness.
That is amazing. So just while we're getting closer, I'll just, I was going to have a big long spiel about this, but I'll just wrap it up with a few dot points. So they provide homes, food and shelter to heaps and heaps of organisms. They also recycle themselves and create more structure for them to grow on. And they actually also can benefit us in that we can use them for food and medicine. Also, there's a lot of things that come out of coral reef compounds that people use in medicine. Now, they also protect the shoreline from being eroded from wave action, so they actually buffer this wave action. Now, there are so many other things that coral reefs are important for, but let's go to this grey angelfish now.
Yes, please. We've got a great close-up of it just hiding out in the reef. So they are your favourite, Pat, and we did deliver for you, Yvonne.
Yes, I'm very happy. That's such a good coincidence that someone requested this, Yvonne requested this, and we got it because this is literally the second one we've ever seen on a live dive. So we are more often seeing the French angelfish and the queen angelfish here on the reef and the rock beauty. So they are the three species we usually see. The grey angelfish we do see, but that's generally over near the wall or on our boat dives.
Yeah, so we've got a really close-up of its face. Oh! A very good close-up of its face there. It's wider mouth. It has a much wider mouth than other fish because it is an omnivore and it just loves to feed on sponges.
Yeah, they are quite a generalist feeder. They do eat a whole range of diets. And as Lauren said, one of these is sponges. Now, sponges are not very appetizing, to say the least. They are made up of glass spicules. So spicules are their skeleton structure, essentially. And yes, they're made out of silicon or glass. So first off, you wouldn't really want a belly full of glass. Now, second of all, because sponges are sessile animals, meaning that they're attached, and they don't really have any way to move or do anything to defend themselves. The only option they have is chemical defense and deterrence. So they're also filled with all these nasty and noxious chemicals. Yet, some fish have evolved to eat them, such as the angelfish, or even some reptiles like the turtle. So, scientists believe that this evolution to eat sponges in angelfish is a recent development because of the pressure there is for other resources here on the reef. So, this grey angelfish and other angelfish have evolved recently to combat that, to eat something that not much else eats, which gives them a huge advantage over the competition, because the food that everything else eats is obviously in competition a lot, whereas the sponges they just leave.
Yes, so a big shout out to Lady Starfire who's joining us on Twitter. It's nice to have you with us, and do send any questions that you have. We're obviously on a streak of good luck and able to find the things that people are requesting at the minute, so next you're on an octopus, Pat.
Well, you never know. I'll be keeping my tentacles crossed.
So Sarinth is asking about Christmas tree corals. So I think you might mean Christmas tree worms. They're not actually coral, but they do live in the coral. So maybe if Pat does spot any, he can point them out for you and we'll give you a better description.
Yeah, definitely. There are Christmas tree worms all over this reef, so I'm sure we'll find one during this dive.
So for some reason the left side of the reef it has a completely different topography, and there is a lot more Gorgonians. So as you can see from this sort of landscape, or should I say seascape, there is just Gorgonians everywhere swaying about in the currents. So it is completely different from where we dive at the right side.
I think we have 2 parrotfish mating right now. Yes, we do.
Oh. Okay, it's out of focus for us at the minute. Did we interrupt them? Is it over?
Did you see that at all?
No.
So, this male parrotfish, right, it was just, no, it must, yeah, it swam off. So we have a male and a female. Oh, here we go, it's going again over here with a different female.
We're completely out of focus, so we're not really able to...
So Rian, if we can follow this male parrotfish that's swimming towards us now, it's just mated twice with 2 different females, and generally when they do this they will do it in a succession of a few females, so it might do it again if we just stay on it. Oh, that damn fish is telling it otherwise.
How naughty, 2 different females in the space of a minute. Now, we did see on dive 1 2 male parrotfish fighting, having a territorial dispute, and now we're seeing a male parrotfish on the hunt for females.
Here we go, it might be locking in on this female here.
Yeah, we can see it.
Oh, here we go, yep, there. So what the male is doing right now is trying to get its attention by giving it little bumps and swimming around it. Now if it likes it, they will swim upwards in the water together and release their gametes.
Oh, well, that wasn't the gametes, FYI everybody, that was a poop. Just as Pat said that, it pooped.
So,
it does look determined.
It does, it must be right now, ready to go. Let's just keep watching it, although it does appear to have given up, I think.
We can still follow it.
Yeah, well, that is, well. Oh, it's coming my way. I hope it doesn't think that I'm a girl.
So while we are following this parrotfish, would you like some questions, Pat?
Yeah, send them in.
We've got a great one from Jeffrey from Texas on Twitter. What is the most camouflaged fish on the reef?
The most camouflaged fish? Ooh, that is a good question. If it was the most camouflaged animal, I would have to say the octopus, just because they can camouflage themselves so well by both changing colour and shape.
Which is why we never see them.
Yeah. In terms of fish themselves, I reckon the trunkfish is pretty good at camouflaging itself. So they can lighten or darken their coloration to match their surroundings. And they sit very, very still next to sponges called Gorgonians of similar colour to them. So when they do this, they can blend into it very well. Like, sometimes you can't even see it.
Well, I would personally say maybe the flounder or the scorpion and stonefish. These fishes are incredibly camouflaged to the point where you almost don't see them at all. So the stonefish and the scorpion fish are very closely related, and they are very dangerous. They contain a lot of venom, and they just tend to lie on the sea bottom and just disguise themselves as a little rock. They're very difficult to see. And the flounders are normally in the shallows. We always look for them, and they are also pretty difficult to spot. So there's a huge array of fish that are really good at camouflage.
Yeah,
So sorry.
You're right, what were you saying?
Child of the Universe is asking a really good general question while we're just looking at this beautiful, intricate coral here. So, Pat, how did the reef topography build up?
Well, that is a very interesting question, and to answer that we have to go back very, very far in time. So coral reefs are essentially just a build-up of calcium carbonate. So many, many years ago, the reef would have been low-lying, and through changes in geology and changes in water level, the reef would have been exposed to different levels of sunlight and different changing environments. Now, over the years, these reefs have built up and broken down and built up and broken down. But the essential part of all this is that the calcium carbonate, which is what corals use as their skeleton, is being recycled essentially and built up. So now we're sitting right on the top layer of this big calcium carbonate buildup, which is where the Grand Cayman Islands sits. Now the Grand Cayman Islands itself is this calcium carbonate, and it was once engulfed with water, but now the waterline has receded. We can actually see all of the remains, the fossils of the old coral reefs that the island once was. So because this water level has come back down, we are now sitting on the edge of where this build-up is, and as we're in a relatively shallow amount of water, this is why these coral reefs are remaining here, because they're in the optimal conditions on top of this big platform of calcium carbonate, where they can be close to the sun, so the algae that lives inside of them can still provide energy and nutrients for them.
Great explanation there. And we do have some questions on Twitter about those parrotfish. So if we do see a parrotfish nearby right now, let's zoom in on it. But Aqua is asking, do parrotfish create cocoons to sleep at night? And yes, they do. So it is a really unusual sleeping habit, and notably it's the queen parrotfish that does it the most, and they cloak themselves in a mucus nightgown secreted from their mouth. So it looks like a big bubble which covers the entire body, and people call it a snot bubble, but I think nightgown is much better. And it's completely transparent, and it is believed to mask their scent, so the night prowling predators will not be able to smell them. So they would be visible, but remember it's nighttime, so there's no light, so these predators can't see them anyway. So they've taken it a step further and masked their scent. So great question. And Pat, one for you. Lady Starfire is asking, what is the reproduction process of the parrotfish? How long for the eggs to hatch?
Sorry, can you please repeat that question?
What is the reproduction process of the parrotfish?
Alrighty, so what I just saw, unfortunately we didn't get a good shot of it on camera, was the two parrotfish, the male and the female, were swimming around one another in the top of the, oh well, not the top, but they would rise up off the reef. And once this courting ritual is complete, they shoot out their sperm and their eggs, which is called broadcast spawning, because they're broadcasting it around. Now, the eggs and the sperm, hopefully, if everything goes well, will fertilise and become a zygote, or a fertilised egg. Now, this fertilised egg will then drift in the current as plankton until it hatches as a juvenile or larvae fish, which will then develop into a juvenile, and then they will go to an initial phase, which is the female, and then if the conditions are right and there's no other male around and they are the dominant female, they will transition into their terminal phase, which is a male, and the life cycle then repeats.
So I hope that answered your question. And Linda, can I please have a coffee as well? Send one over my way. So we've got a lot of great questions, and please keep them coming to whatever's relevant on the screen.
So I want to show you all now this very big and beautiful Gorgonian. Now this one has all of its polyps fully extended, and they are quite sizable polyps. So it should be good to show you just how intricate the makeup of a coral is. So just this one here, Rhea.
Yes, we've got a great, beautiful, clear sight of that. Yeah, we're really close in now, Pat. So you can see this Gorgonian has all its polyps extended, which is why it looks hairy or fluffy. And it's feeding. So if we can just get a still shot, you're able to see these tentacles actively moving and trying to capture a bit of food from the water column.
Yeah, and we can really see quite a lot on diveLIVE. We'll make a comparison of the polyps of a coral through an anemone, a small anemone. And now that we've got zoom, I can finally show you just how similar the structures are. So we can see each one of these little polyps, the polyps being the animal. So this is just one animal. So there is thousands here on this one Gorgonian. But these polyps are their feeding structures. So it's just 8 tentacles around the mouth. And now we know this is a Gorgonian because there are 8 tentacles on the single polyp. So that is why we call Gorgonians octocorals, whereas stony corals, the ones that actually make up the reef, are hexacorals because they have 6 pair of 6 tentacles or multiples of 6. So we can see here this one has 8. So that's how we know it's a Gorgonian octocoral. And another identifying feature is each tentacle, I'm not sure how well you'll be able to see this with zoom, but each tentacle has little hair-like projections coming off it called pinnules. And now we do not see these in stony corals, but we see them in Gorgonians. And what these structures do is just essentially increase the surface area to maximise their chances of catching something that they can filter out.
Well done, Rian, and getting this beautiful images that we have in front of us right now. It's incredible how close we are. And you can see that it's just swaying with the water movement, which is much beneficial to the animals this way because they can try and capture as much food as they want with those tentacles. Now, Pat, everyone was just loving the parrotfish, so I'll answer some questions, but can you give us an air check, please?
Sure, Kat. I am on 100 bar. And Rian, can I get an air check from you, mate? Because I can actually see that your tank is leaking a little bit, so we don't want you running out of air either.
So while you're checking, thank you, Dharma Punk, for the lovely compliment. It really makes me smile to know that you really love watching this. And Lady Starfire was mentioning on Twitter that fish are born... Oh, hold on one second. Yeah, fish are born one gender instead of the other. So do they have the organs of both genders or do they develop later? Now that's really interesting because the form of sex change that... Oh, we have a little cowfish ahead of us, I think. The form of sex change that parrotfish do display is called protogyny, and that basically just means when it's a female first and it will change into a male later. There is also protandry, which is where it's the other way, the opposite way, a male first. But the female first is much more beneficial because basically being a male rocks and he gets to have a lot more sex on the reef. So it's much more beneficial to be a female at the start of your life, being looked after by a male, and then turning into a male at the end. So you can really mate with lots of females. And about 75% of the 500 known hermaphroditic species are this way. They start off females and then they go to males. So how this works is normally between steroid and hormonal changes that take place in the fish will convert them. So they don't have both organs. That would mean that they would be a completely different type of hermaphrodite. The hamlets that we do sometimes show you, they do contain both sex organs, so they are a sequential hermaphrodite.
So, I'm just trying to catch up to this cowfish here. It's just cruising at a pace that's just a little too quick for us to get close. But we are catching up now, because this one is actually showing some bright blue coloration, which is really cool.
Not able to see anything right now. Oh yes, we can. My apologies. Right ahead of us, just above the sandy bottom, we do have a trunkfish, not a cowfish.
See that it's gone bright blue.
Yeah.
Now, this I saw the other day when it was mating, so I'm not sure whether it's gone bright blue now for mating purposes. It is a brilliant display.
Yeah, so you noticed there was no spines above the eyes, so that means it's not a cowfish. You can see that there's 2 spines at the back of the body, which they can regenerate if broken, and that's how we know it's a trunkfish. So this is a honeycomb trunkfish. Oh, wait, there is a spine above one of the eyes.
Yeah, so that's why I thought it was a cowfish, because it did have one spine, but one must have been broken off, I guess.
Oh, wow. Okay, so that's why we got confused there. So, my apologies, it is indeed a cowfish. So it's probably in the process of regenerating that other spine. And it seems to have changed colour, Pat. It seems to have got a lot darker.
Yeah, so that blue coloration is almost completely gone now. So why it had that turned on, I actually have no idea. As I said, I've only seen them doing that in the mating process.
So Paula has mentioned that she never used to think of corals as alive, and that's fantastic because they are animals. Yeah, we can really see just one spine there and one spine is missing, and this fish is currently being cleaned by little gobies. So you can see the smaller fish, which is sort of scurrying all over its body. It's actually actively cleaning it. It's removing maybe algae and parasites and all sorts of things that are stuck to its body. This is great, Pat.
Yeah, this is really cool. Obviously getting, oh, it must have got irritated with that cleaner fish there then.
Yeah, sometimes when they pull out parasites, it can actually be painful for the fish and they do flinch. I actually think this is the best footage we have of a cowfish so far.
Yeah, it's great. It's really turning those colours on and off right now.
And normally they're quite shy, so they just swim away using that sort of dorsal and pectoral and anal fins. They're not using their tail fin.
So they are, yeah, very odd shaped. They are extremely odd shaped actually, but all of these different shapes all have their advantages for different animals. And now this fish, its bony skeleton also serves kind of as a bit of a deterrent to other predators, because they don't want to be getting a mouthful of bones, but with this fish, that's all they're going to be getting.
So Jeffrey from Texas was asking about coral spawning. There's been a few other questions about coral spawning, and one particular mention of the Great Barrier Reef. So normally corals on one reef do have synchronized spawning, and the Great Barrier Reef is the most famous example of that. So all the corals will spawn at the same time. So it's not always the same time for each country and each region, but within the specific localized area, it's very common for all the corals to spawn at once, and this increases their genetic diversity. So it's much more beneficial for them all to do it at once than for different corals to do it all out of sync with one another. So we will need to investigate when the coral spawning does occur here in Grand Cayman.
Now, Rian, if you could come back this way, Lauren was mentioning sequential hermaphrodites before, and I have found a hamlet.
Oh, I meant to say synchronous, sorry. So the parrotfish are sequential and the hamlets are synchronous.
Yeah, so this means that they have both female and male gonads, and so can produce either sperm or egg. Now, I have found a little masked hamlet down here which does exactly that. So when two hamlets are courting or mating together, one will assume the role of the female and one will assume the role of the male, even though they both retain both of the sex organs.
This is a great find. We're getting a great view of this masked hamlet. You can see the black bars on the eyes and the black fins with the white body. And yes, as Pat mentioned, when, well, you can't say boy and girl, I guess. You can say when a masked hamlet meets another masked hamlet, one will automatically just choose that it will be the male, so the other one will just in turn choose to be the female. So they are a great example of synchronous hermaphrodites.
And what's even more interesting about the mating of these fish is that they can actually interbreed with other species of hamlets and produce hybrids. So a hybrid is the offspring of two separate species.
Linda's actually asking why it's called a hamlet. I'm not sure. Do you know that one, Pat?
No, I actually have no idea, sorry. I'm wondering whether it is anything to do with Shakespeare or theatre.
Yeah, I'm really not sure. We'll need to look that up. Why fish, particularly these fish, get their names is often a really interesting story. So we will find out for you why these fish are called the hamlets. So we're getting a really, really clear view of this fish, and it's really beautiful.
Now, hamlets do tend to inhabit deeper waters, and they are very shy creatures as well. They tend to not display themselves too much. So it's always really, really special to see a hamlet here on the reef.
So Pat, a question for you from Aqua. Are there any creature in the Grand Cayman reefs that are live bearers and not egg layers?
Any creatures on the reef that... Sorry, what? Yeah, live, yeah.
That are live bearers and not egg layers. So I think that would be mainly referring to, for example, your sharks and your stingrays are perfect examples. They actually give birth to live young in a form of reproduction called ovoviviparous. So they do not lay their eggs on the sand. They actually do give birth to live young once they hatch from eggs inside of them.
Yes. And apart from that, I don't think there's anything else that's frequent here on the reef that really doesn't lay eggs. I mean, sponges, well, technically sponges, they are internal fertilizers. But what is this? We have a grouper, a bright yellow grouper. That is amazing. Now, I do not know what species of grouper this is.
Oh.
I have to see that.
Let me have a look for you, but we've never seen this one before. A new species alert. So I'm going to check this out because I don't know what species this is either.
I have a hunch that this could be a juvenile of a different species of grouper.
Can we just get another look at this? The tiger grouper does have a yellow juvenile phase, but it does have a bar going along the body. So there doesn't seem to be a bar here. So let us continue looking. But what a great find. This might become one of our favorites. Look at that color.
Really, really cool. And it's obviously stopping there to get it clean. What a magnificent fish.
Does it have any blue dots on it, Pat? I can't see them. No.
Whereabouts would the blue dots be?
Just on the body. So there is a bright yellow coney, but they do have blue dots on them. This is interesting, and you can really clearly see that lateral line. So while I'm looking, Pat, do you want to explain what the lateral line is?
Yeah, of course. So the lateral line that Laurie is referring to is that line that's running down the side of its body, or its pectoral side, from just behind the operculum, or the gill covering, all the way down to the tail. And now this lateral line is very special adaptation in fish because it's actually a sensory organ for them. So the line is a bunch of claws all lined up with tiny little hairs coming out of it. And what these do is they pick up changes in water movement and allow the fish to, in a way, feel or sense movement rather than see it.
Yeah, it's an extra sense that we do not have. We don't have the privilege to have or really technically understand it. So, Pat, I would only imagine this species could be a coney. There are different, this would be the golden variation, but I cannot say this for sure. So we are going to have to research this more to find out what species of fish this is.
We have a bit of a mystery here.
Yeah, well, I've never seen it before, so I don't believe you have either. So this is a new one to the ever-growing species list of diveLIVE.
Yeah, that's great.
If anybody watching knows what it is, please feel free to share with us.
Yeah.
Unfortunately, we're not able to know all of the fish, but we are working on it. So if it was a coney, it would have blue dots. So we can see a blue dot under the eye, but there would be a lot more than that. And the juveniles also have blue dots. So we could...
What it's doing right now is very strange. It's only opening up one side of its gill covering, or its operculum, at a time. So it's lifting one side. I'm assuming there must be something inside of it cleaning each side of the gill.
Oh, I can see a little goby in the mouth. Rian's captured that really well.
Ah, so it must be just allowing that one in and out. So I've never actually seen a fish move its gill coverings independently though, so that's pretty cool.
Yeah, just now that we have Zoom, we're just able to see cleaning in such more detail. So we used to speak about it a lot, but now we're actually able to show you. So the fish is a little bit out of focus, Rian, so if we just get it back into focus. There we go.
Well, I have hit 50 bar now, so we'll have to leave this mysterious little critter. Lauren and I will hit the books and hopefully be able to find out just what it is.
Yes, we will, and we will report back. But just before Pat wraps up, just so that everyone watching knows, we will not be broadcasting tomorrow. There will be no live dives tomorrow. They will resume on Tuesday with both Pat and I at the normal times of 7 and 11. So make a note that there will be no broadcast tomorrow.
Yes, thank you for reminding me about that, Lauren. So yes, as Lauren said, no dives tomorrow, but we did have 2 grunt dives today. I hope you enjoyed being down here with me, and thank you so much for joining me. Thank you, Rian, for doing the great camera work, and thank you, Lauren, for always having my back up on the surface. So just to really drill it in, no dives tomorrow on Monday, but we will be back 7 AM Tuesday morning, around Cayman time, and I hope that you can all join us down here to dive with us again. Thank you, everyone.
Thank you, Pat, and thank you, diveLIVE family, for your continued support. See you on Tuesday.